1.3. Often when beginners are asked to write a program to solve a problem, they just start writing code right away. This is a horrible idea. Doesn't in some cases doesn't matter if the code is right or if they even understood what they were doing. People really like filling up screens with text. In 108, it seems like we teach the function design recipe, which I'll just quickly open in case you have forgotten. In my case, I just noticed it because I haven't done 108 before. But I know what's taught in it, so that's what matters. What is the recipe for designing functions? You start off with some examples so that you know which inputs lead to certain outputs. You put in a header and outdent it. So choose a meaningful name for your parameters. Include the type contract, which is what are the types that these things are supposed to be and what's returned, if anything. A description in plain English, what is this function going to do? The body itself, indent it to match the doc string for nice formatting, and then test it. And this is the real chunky part of getting things going, is doing actual good testing on some tricky cases, for example. Okay, function design recipe, something supposedly that you're already quite familiar with, and if you're not, you can always review. Now, by following the function design recipe, you delay writing the code a little bit until you've written the doc string and some examples for the code, which usually will help you, I think, when it comes to actually writing the right thing to do what you're trying to do. It's a good habit to follow, I would definitely agree, and your future self, as well as your teammates when you have them, will thank you for doing this. Now, there are some parts of this that we want to expand a little bit on. For instance, docstring preconditions, type contracts, and testing methodologies, all very important things in computer science. Now, for any function to work, it's pretty important that you let anybody using your function know what the preconditions are for it to actually be called. Most of the time, if you're writing code, it's not just for you. Someone else will probably use it at some point. Otherwise, no one really cares. And so if you're writing libraries for people or you're writing software that some company is going to use, they probably will need to know what your code is doing at some point. The docstring of a function describes not only what the function is supposed to do through text examples and so on, but also what are the requirements in order for this function to be used. So one of these requirements is the type contract. It requires that whenever someone calls your function, the arguments that are provided must be of the specified type, or your function's not going to behave as desired. So here is a function docstring. Decreases at, given a parameter numbers, which is a list of integers, and it's supposed to return an integer. And according to the docstring, it returns the index of the first number less than its predecessor. So if we see decreases out of this list, the index of the first number that's less than its predecessor is 4. And let's see, 0, 1, 2, 3, 4. 2 is the first number where it is less than the one that comes before it. We know decreases at expects to be called on a list of integers. If we don't give it a list of integers, let's suppose we give it one integer, or we give it, a list of strings. I guess actually a list of strings will probably still work, so maybe we don't do that. But you just give it one number. It's not necessarily the case that your function is going to work properly. Maybe you were clever about it and figured out how to get around that. But it's expected that by having this type contract, you are offering this guarantee that so long as you have given a list of integers, it will do what it's supposed to. And if you don't give a list of integers, who knows? In practice, you often want to extend this idea by specifying what's the required type of the arguments. So for example, you might want to say, the function must be given numbers between 1 and 10, or the first argument must be bigger than the second argument. A precondition of a function is any property that the arguments must satisfy in order for the code to actually do what it's described to do. They are pretty much always included in a function's docstring, or should be included, and are a crucial part of the interface. As a user of a function, you need to know preconditions. They tell you how to use something. They also limit how a function can be used. On the other hand, preconditions are very helpful for you if you're the one writing this code, because it frees you up from not having to worry about, oh no, what happens if they give me a floating point number or something? You can assume that won't happen by having the precondition listed as part of what your function has. Let's consider a method for searching a list, right? Binary search is one way you do this, but you need to have the list sorted already. If your search method has to confirm that the list is sorted before it does anything, well, that makes it worse than just checking one number at a time, which is terrible. So instead, we say as our precondition, the list that's provided must already be sorted, or there's no guarantee this code will do what you want. Bottom line is that preconditions are part of function design. It's specifying precisely what service you want to provide to the users of your functions and what restrictions you want to impose on them.